Hello, and welcome to our session today at EclipseCon. In this session, we're going to talk a bit about how we can make integration testing in OSGI easier for you. And in particular, we're going to be talking about a new open source project under the OSGI organization at GitHub called osgi-test. We have a few speakers with us today. They're going to bring us up to date on what's going on in the space. Myself, my name is BJ Hargrave. I work at IBM. I'm a senior technical staff member in IBM's developer ecosystems group. Longtime OSGI person, been involved with OSGI for many, many years, and also do a lot of open source development. So I've been one of the leaders of this particular project, osgi-test. Also today with us, we have Ray Auge. He's a senior software architect at Liferay, a long-time also open source developer, and he's a member of the Apache Software Foundation, and he's been sort of heavily involved in OSGI for many years as well. And third, we have Father Jeremy Krieg. He's the CEO of the Greek Welfare Center of South Australia, which is part of the Greek Orthodox Archdiocese of Australia, and he's been a long-time open source testing enthusiast. He's quite an expert in many areas of testing in Java. So first, what is the osgi-test project? Right, so basically this was a confluence of some people that worked on both OSGI and also the BND and BND tools development maintainers. And we decided we wanted to create a new project to really facilitate and ease some of the work that has to go on with testing, and specifically in situ in an OSGI environment for developers. So our goal was really to make it easier to write those tests, remove a lot of the boilerplate you have to deal with, and really make it sort of smooth and fluid on doing your OSGI integration tests. And so we basically, in this project, we have several different bundles that are available to you that based upon what your needs are, right? We have at the base a common utility library. This is used by a number of the other projects in the osgi-test repo. That has some really good stuff, including some sort of things that are useful in OSGI for dictionaries. We're also big fans of AssertJ as a testing technology. So we have some OSGI specific custom assertions for AssertJ. And we have some support for both JUnit 5 in the form of test rules and JUnit 4 as test rules and JUnit Jupyter's extensions. BND has some support for Maven, Gradle, and also Eclipse. And this, we're going to have an example here where we're going to show you using Maven to do it. We're still in the early days of the osgi-test project. So we have, right now, you can get from Maven Central our 0.10 release. And so next, I'd like to hand it over to Father Jeremy, who's going to take us through some more detail specifically on what is in the AssertJ support and the JUnit support. So Father Jeremy, over to you.
Thank you, BJ, for that wonderful introduction. My name is Father Jeremy Krieg, and I'll be taking you through the overview section where I'll look at the main features of the test support in osgi-test. And the first main section of support we have is AssertJ support. So for those who don't know what AssertJ is, a quick introduction. It's an open source project with the lead developer Joel Costigliola. It's comprised of a series of open source domain specific assertion libraries, and the core library, AssertJ core, is a series of assertions centered around the JDK. There are others for other different Java libraries as well. AssertJ the core module is a fork of the original Fixtures for Easy Software Testing project, FEST, by Alex Ruiz, which Joel took over. And as you can see, it's quite a popular library. Why AssertJ? Well, there's lots of reasons, and we'll see some of those in the examples to follow, examples of these reasons in the examples to follow. The first is that it's a fluid API. It's easy to read and understand even for non-developers. The API design leverages the IDE's auto-completion ability to make writing tests easier. Object-specific assertions provide more informative feedback about test failures. So because you know more about the object you're asserting on, you're able to provide more information about the failure if one occurs. AssertJ also has soft assertions, which allows you to perform multiple assertions per test method. And this is useful if you're running tests, assertions on slow code. If you're doing integration tests, for example, rather than have to run your code once every time and do one assertion every time you run it. You can run the slow code once and perform multiple assertions, and all those assertions will run, and if more than one fails, you get feedback about all failures rather than just the first failure, as you would with hard assertions. You can chain assertions on a single object, which makes the code read much more concisely. It's extensible, so as you saw on the first page in osgi-test, we've leveraged this as well. You can produce your own domain-specific assertions. It's test framework agnostic, so it'll work in JUnit 4, JUnit 5, or TestNG or anything. And it's OSGI friendly, so it had OSGI support to begin with, but through our involvement with osgi-test, some of the core team have made some improvements to the AssertJ core library as well to make sure that it works well in an OSGI framework. So here's some example of what the code looks like in the various different forms. And the regular Jupyter assertions or JUnit 4 assertions style, you can see on the first section there. The main difficulty I find there is that I can never remember which way around the actual and expected values go. And also, as we'll see, you can't use the IDE completion to look at the specific different types of assertions. You have to remember that assert equals is your method. Whereas with AssertJ core, in the next line, you've got assert, you just type assert that. All the assertions will start with assert that. And then when you get to the last bit, and we'll see in the next slide, it'll show you which assertions are available for that object. So the other advantage of the AssertJ syntax that we see in the second line there is that it's easy to remember which way around the actual and expected is. So over here on the right, is equal to resolved. We know that this is what we're expecting it to be equal to. So this is our expected value. This is our actual value that we're testing. And this is the final example here is what it looks like using an osgi-test custom assertions. So as you can see, there's only one assert that statement, and the two different assertions here are chained off of that one assert that. And we have a nice, easy to understand is in state method where you don't have to fiddle around with the bitmap masking and everything. You just provide it with that one state and it will tell you, test that state for you. Now, this is an example of how the IDE completion works. So as you start typing the first few letters of the assertion that you want to, the object that you want to assert on, it'll tell you what methods are available to assert on for that object, which is very useful if there's lots of different ones and you don't have to remember them all. So the output of the different assertion types is also something that distinguishes it. So this is what it looks like from the standard regular Jupyter assertions. Expected 0 but was 4. Okay, well, I don't know what 4 was. I didn't put 4 in my code. I put resolved. But that obviously is a constant and it gets lost at compile time, and so it has no way of knowing. So all it can give me is the number. And the other thing we can see here is that I accidentally swapped the expected and the actual value. So that's the mistake that I referred to earlier. So with regular AssertJ, things are slightly better in that I've got my expected and actual round the right way, sorry. But I still don't know, unless I'm really good with my numbers, I can't remember what state 4 is, and 0 doesn't tell me anything about the state that the original bundle was in because I've masked out the resolved bit, which wasn't set, but it doesn't tell me anything about what other bits may have been set in that mask. One other thing where the AssertJ syntax helps is this being on separate lines, whereas on the standard Jupyter assertion, they're on the same line. If these are long values, they can be harder to compare, whereas lining them up like this as AssertJ does means you can visually compare them a little bit easier as you're scanning through a log or on the screen or everything. But where it really shines is we have the custom assertion as we have in AssertJ OSGI. And as you can see, it gives you everything you need to know. It tells you that you're expecting it to be in state 4, which is, it knows is the resolved state, but that it was actually in state 32, which is the active state. And as a bonus, it will actually tell me the name, the BSN of the bundle that the test was performed on. So that all those little bits of information just give you that head start when you go into start debugging why that test assertion failed. So moving on now to our JUnit support in osgi-test. What is JUnit first of all? I'll go through this quickly because I think most of us are aware of JUnit. JUnit 4 has been around for a while, has been the mainstay of Java unit testing. JUnit 5 is a successor, which is comprised of the overall test running architecture abstraction, the JUnit platform, which is able to run different test engines, discover test engines and run them. So you can actually have multiple different types of test engine in your test, and you can combine them using JUnit platform. The JUnit vintage engine, let's see the last line there, is an implementation of a test engine wrapper around JUnit 4, and the JUnit Jupyter engine is the new engine, what most people think of when they think of JUnit 5, the new syntax and the extensions and everything that we have with JUnit 5. The JUnit platform architecture is very useful in that you can combine different types of test engine together in one test. It's helpful for migrating from JUnit 4 to JUnit 5, for example. JUnit and OSGI has had support for some time, so JUnit 4 has had OSGI bundled versions for a while in the Apache Service Mix, for example, and Eclipse since Oxygen has also had them on the orbit for JUnit 5. But most recently, Auge has added the OSGI metadata to JUnit 5 bundles in Maven Central, so you can download them straight out of Maven Central and use them straight away since version 5.6 of the engine 1.6 of JUnit platform, which is very useful. So there's PDE support for running JUnit 4 and 5 in an OSGI environment. An OSGI test should be able to work in that environment too, although we have not tested it. We have tested it extensively using BND and BND tools, which is obviously our preferred mode of development. And since version 5, there's been support for JUnit 5 through the JUnit platform tester bundle. So the support we have in OSGI tests, and we'll go through these in a bit more detail in the slides to come. So there's a series of extensions there, and in some cases a corresponding JUnit 4 rule. But most of our recent development has been on the extensions. So although the extension and rules had very similar functionality originally, more recently the development's focused on the extension, and the rules functionality has been left behind somewhat. And in fact, in the case of the configuration extension, it doesn't have a corresponding rule at all. We have felt that it's been a better use of our time to focus on adding the new features on the JUnit 5, because that's where we think testing should go in the future. And it's usually pretty easy to migrate. There's not too many reasons to stay on JUnit 4 unless you're using some old rules or something that don't have a JUnit 5 counterpart. And in that case, there's still the JUnit 4 rules, although the functionality is somewhat more limited. So the bundle context extension is the first one I'll look at. It basically will inject the bundle context into your test class, either as a field or as a test method, as a test method parameter. That in itself is useful, but what's really useful is that it will automatically roll back changes to the bundle context that you make during the test. So for example, you'll see when Ray does the live demo shortly, there's a few calls to a register service through the bundle context, but there are no calls to unregister service because the bundle context extension automatically does that for you. The bundle context extension also provides an install bundle interface, which you can inject, which is useful for installing embedded bundles. So you can have a bundle embedded inside your bundle and then use that bundle to install into your running test, which saves you having to mess around trying to find the bundles that run at test time. And again, the bundle context extension will remove that bundle, uninstall it at the end of your test. And finally, the bundle context extension supports multiple different levels of scope, so you can inject the service bundle context extension at the before all phase of your test, and it will remain in scope for all the test methods of your test and be removed when your test class ends. Or you can do it per method, or you can do it in nested classes, etc. The service extension is used for getting references to services. So it's kind of like having the convenience of declarative services, but within your test method, your test class. You can inject them as a field or as a parameter using the inject service notation. You can configure this annotation by cardinality, specifying how many services you want to wait for, the filter for discovering the services, and the timeout, how long to wait for those services to appear, etc. And then the extension will take care of setting up your service tracker and doing all of that low-level stuff, waiting for the number of services to arrive. And that point there is actually one of the most useful features of this extension, because we found in our own development that it's quite error-prone and tricky to catch and avoid all the possible race conditions that can occur there. And finally, it will make sure that all the service references that you generate, that you get during the test, are automatically cleaned up when the test scope ends. There's also a service-aware interface which you can inject, which you can use if you need to introspect the underlying service tracker state. Either that or you can inject the references to the service directly, which is if you don't need that introspection capability. The final extension that we have, this is the newest, injects configuration instances into the running test as field or parameter, and allows you to declarative create configurations with the osgi configuration admin service. And as with our extensions, it will automatically clean those up at the end of the test once the test scope has ended. There's no JUnit for rule counterpart for this at the moment. And the osgi team wishes to acknowledge Mr. Stefan Bischoff, who's another BND contributor who contributed this extension to osgi-test. So that's an overview of the extensions we have available and the assertion capability. I'll now hand over to Auge, who will show you how all this works in a real testing scenario.
Thank you, Father Jeremy, and welcome everyone to the demo portion of our presentation. Today, we're demonstrating how to use the osgi-test project to test osgi bundles in a real osgi framework. Let's switch over to an editor and take a look at the project. So we're using a Maven project today. But I should clarify that the osgi-test project works in any of the build environments that BND supports. Let's start by looking at the parent/reactor POM, where for convenience, we've pre-configured several plugins related to setting up an osgi testing environment. First of all, we're building osgi bundles, so we need the BND Maven plugin to create the metadata and to generate the metadata for our bundles. Next, we have the BND Resolver Maven plugin, which serves two purposes, the main purpose of which is to generate or calculate a solution from the initial requirements, which are the bundles that we're building and their dependencies, to produce a runnable solution, a runnable collection of bundles, which we can then execute. Specific to this particular demo today is the BND Testing Maven plugin, which takes the solution calculated by the BND Resolver Maven plugin and then executes tests within that, that solution, that assembly. Next, we can see that our project has three modules. It has an API module, and it's very simple. It has a ball interface and a player interface. And we're building osgi bundles, but you'll notice that we're using bundle annotations to control the metadata generated for our bundles. And here you can see in the package info file that we have the version annotation and the export annotation. And otherwise, the POM file for that module is pretty sparse. It does have the BND baseline Maven plugin, but that's not specific to our test scenario. This is really a sanity check to detect any unwanted or accidental API changes. So it's important, but not necessary for this test, but it is a good sanity check. Next, we have the impl bundle. The impl bundle has an implementation of the player interface, which is published as an osgi service using the declarative service component annotation. You can see that the bundle here is the configuration again is fairly sparse, and here we just have dependencies, and all of the metadata is calculated by BND. There isn't a test, a regular old open box JUnit test here, just for to prove that that still works, that functionality is supported. And finally, we have our integration test bundle, which we've separated out just for simplicity of configuration and to be more illustrative. We're going to start by looking at the POM file. The POM file has several plugins configured, or reconfigured rather. The BND Maven plugin, we're using its BND process test goal to process the test classes. And we're using the Maven jar plugin to create a test jar from those classes. Next, we want to look at the test BND run, which is the runtime solution. The configuration is the run descriptor. The first thing to point out is that we have reconfigured the tester implementation to be the JUnit platform implementation to support JUnit 5 or Jupyter. But there are several other instructions here that configure various other aspects such as the framework, default properties, logging configuration, and so on. But the most important part to note here is the run requires instruction, which lists the initial requirements, as I mentioned earlier, that the resolver plugin will use to calculate the runnable solution. And you can see here that we've included our test jar in that initial requirements, and also the Jupyter engine and Jupyter Platform Launcher. What you should note is that the solution calculated by the resolver is the set of run bundles here. This is not maintained by hand. This is calculated by the plugin. All right, let's look at the test code. A couple of points to note here is that we have two test extensions configured, the bundle context extension and the service extension. The bundle context extension allows us to inject either into a field or into a test method parameter a bundle context. The bundle context, as Father Jeremy mentioned earlier, is managed for you in the sense that any cleanup that needs to be done is handled by the extension. And then we have the service extension, which allows us to inject services into our test class via fields or test methods. And services have different aspects that can be configured through the inject service annotation, cardinality, target filter, and even the timeout. And you can see here, we can use the assertions on the services to check various aspects. Now, when you want to access more information about the service, you can inject instead a special type called service aware, which allows you to introspect several other attributes and properties of the service or of the service tracker behind the injection. All right, let's run the test. First, we'll go to the command line and execute the plain old Maven clean verify. And you can see my tests here have executed. 3 tests were started and 3 tests were successful. Well, let's move over to our Eclipse IDE, which has the B&D Tools plugin installed. With the integration, you can see here we have our test and we have our modules loaded into the IDE. And if I execute this, run as B&D osgi-test launcher, JUnit, if I execute that, you can see my JUnit ran 3 tests, and all is well, everything's green. I should point out at this point that I have a new feature enabled that exists in the B&D Tools testing support, which is called continuous testing. You can see that my test environment here is still running, and that offers up some interesting capabilities. Let's go back to the package explorer and we'll open up the test class. Let's see what happens when I uncomment this test here that I have. And save. Momentarily, my tests were recompiled, redeployed, and re-executed. You can see here that I have 4 tests executed and 1 failure. And this test we knew was going to fail. So that demonstrates that. Let's recomment it. Save that and see what happens. Great. All is well. Everything is green again. Wonderful. All right. With that, let's go back and I'll give you the link to the demo code repository. And you can see how this configuration in that repository. All right. Thank you all. Pass it back over to BJ.
Thanks very much for that demo, Ray. It was really good. It's quite powerful what you can do these days. So let me just try and wrap up here. We had a lot of good stuff from both Father Jeremy and Ray. So in conclusion, what I'd really like as the takeaway for the audience is for you guys to try this out and then feedback and contribute. Right, you can go get these bundles right now from Maven Central. There's a link there in the osgi test namespace. In fact, to sort of show how useful these are, we're currently using these now in the OSGI project for some of our compliance tests for the forthcoming release 8. And some other projects like those in Apache Aries and Adempera Test have also started to use this to help them do their OSGI testing. So it's useful today. Please go check it out. There's our GitHub repo. It's an open source project under the Apache license. So ideally, we'd love you to get involved. We'd love your feedback. So please go check it out, try it out. If you have feature requests or bugs you find, please open issues. And of course, above all, pull requests are welcome. So we'd love people to get involved and contribute. So very much looking forward to your feedback on this project, and hopefully you'll find it useful for your OSGI testing needs. So thank you very much. Join the conversation. And just finally, please take a moment to evaluate this session. Hopefully you found it useful. Thanks very much, and enjoy the rest of the conference. Well, hello, everyone. Hopefully you enjoyed the presentation. We enjoyed working on the project, and hopefully we'll get some great feedback from you. I think in terms of questions, we have one question about where the example code is. Ray, I think you can speak to that.
Yeah, the example repo is actually on one of the last slides where I was presenting, but I'm also pasting it here in the chat, and
right.
Maybe our moderator can pass it to the audience.
Right. The other thing we can do, of course, is look to actually include that into the main osgi-test repo. Right. We put that example together for the purposes of this presentation, but maybe it's a good idea to build it into the main repo so that it's more readily findable by other people. And then we got another question that came in too. So basically the question is, what are the advantages or disadvantages of using osgi-test over PACS exam? So panelists, anyone got an opinion on that?
I would start by saying that because B&D is the cutting edge or bleeding edge of OSGI development, it probably supports the latest and greatest functionality, whereas PACS exam is probably likely to be catching up. I'm not aware or unsure of what the rapidity of development is, but I would just say that B&D is more likely to cover more areas more thoroughly.
Okay, great. I don't know that we have any more questions. So if you want to wrap up, Father Jeremy, do you have anything you want to add to wrap us up?
No, I'm sorry, I'm not that familiar with PACS exam, so I don't have much to add there. But if you guys, anyone's interested in contributing to the project, we'd be more than happy to have your contributions, and like to see this project grow and become more useful to more people.
Great. All right. Well, thank you everyone who's attended the talk today, and please go forth and check out osgi-test. Thanks very much.
And we'll leave.